Okay, so we're going to finish up our last lecture in Unit 4 and talk about some applications of oxidation and reduction. So corrosion is an oxidation and reduction reaction. So this is a redox reaction. Those are the reactions that we've been talking about for the past few lectures. So it usually starts with a metal and ends with a metal oxide. This is an undesirable situation where the metal is needed. The metal oxide usually disintegrates into a powder. So you have metal going to powder, and that's no good. Think of your car. You don't want that metal to be a powder, right? You want it to be solid. But also think of a car. When you see that disintegration, it is like a powder. So that's corrosion. So here is an example with iron. So iron undergoes corrosion. It reacts with oxygen in the atmosphere to get Fe2O3. And it's not balanced. Now it is. Okay, so iron is oxidized. Oxygen is reduced. It's kind of a tricky one to see, but just trust me. So iron is the reducing agent, oxygen is the oxidizing agent. So this reaction happens more quickly when water is present. So I'll say reaction rate increases in the presence of water, especially salt water. So this salt water acts as a salt bridge, like what we were talking about with batteries a few lectures back. So this completes the circuit and makes the transfer of electrons easier. Transfer electrons easier. So if you think about winters where salt is used on the road pretty consistently, cars usually suffer rust a lot more. Cars from ocean areas also can become rusted a lot easier. Okay, so that's iron, and that's the reaction it undergoes when it corrodes. Aluminum is the next one we're going to talk about. Aluminum also reacts with oxygen in the air, and you get Al2O3, so 4, 3, 2. So aluminum is getting oxidized, so it's the reducing agent. Oxygen is getting reduced. It is the oxidizing agent. So this product right here forms a very hard and tough layer of on the surface of aluminum and protects the aluminum underneath from any further reaction. Okay, silver. Silver goes from silver to silver plus 1. So this is the oxidation half. And then hydrogen sulfide in the air is the reduction part. So what you get on your silver metal is a black tarnish. And you can use different cleaning products to remove this black tarnish. Okay, another type of reaction. So we've seen 3 examples of corrosion. So it's a redox reaction. Now we're going to look at combustion. Combustion is a reaction between a non-metal and oxygen. So corrosion was a metal plus oxygen. Combustion is a non-metal plus oxygen. So and then you get this reaction. So methane, natural gas, reacts with oxygen to form carbon dioxide and water. Okay, so methane reacts with oxygen to form carbon dioxide and water. So carbon is oxidized while oxygen is reduced. So another combustion type of reaction is where we see charcoal reacting with oxygen to form carbon dioxide. So this is getting oxidized, and this is getting reduced. Okay, so two types of reactions, both reacting with oxygen. One is a metal reacting with oxygen, the other is a non-metal reacting with oxygen. Okay, now let's look at applications of oxidation and reduction. So they're everywhere. You know, a lot of students get frustrated, why do I have to take chemistry? And I know I've said this a million times, but it always bears repeating. Chemistry is everywhere. Chemistry is in your rusty car. Chemistry is in your silver that's tarnishing. Chemistry is in developing film. Chemistry is in how you heat your home with natural gas, methane getting oxidized. Okay, so let's look at some more applications. So film has a coating of silver bromide, which contains silver ions. When exposed to light, there's a series of reactions which end in the silver being reduced to silver metal. So, you know, this is, so much has changed with film, and, you know, think about old film. But it's a very important process. You know, it's changed, even though it's changed. So to process the film, first this amount of silver which has been reduced is increased so that the image is dark enough to be visible. The reducing agent, hydroquinone, is used to reduce the silver. So then there's another reaction that stops the reduction, and then light is used. And so this silver can be recycled, but if you've ever had to work with old types of x-ray machines, perhaps, or if you took a film class or photography class where you had to develop your own images, the chemicals that you use in developing film kind of smell funny. So it's a series of redox reactions, and the end result is getting this silver coating on the film. Okay, hydrogen peroxide is a common oxidizing agent used for bleaching or killing germs. It releases oxygen and is converted to water. Most hydrogen peroxide is sold as a 3% solution. Okay, so you have hydrogen oxide, hydrogen peroxide. So this is getting reduced. So it acts as an oxidizing agent. So oxidation is a very destructive reaction and can kill cells, such as bacteria. So this can kill cells. Many foods and cosmetics will advertise that they contain antioxidants, substances that will react with the oxygen before it does any damage, such as contributing to the aging process. But so this can be good, while you clean wounds with hydrogen peroxide. Eventually, if you use too much hydrogen peroxide, you can damage your own cells. Okay, potassium dichromate. This is used in the breathalyzer reaction. This is what I mentioned earlier to test for alcohol. It is a bright yellow-orange color, but after it reacts with alcohol, it turns blue-green. The extent of the color change indicates how much alcohol is present. It is not possible to prevent the reaction from taking place other than by not drinking alcohol. So this is getting oxidized, and this is getting reduced. And our last application deals with bleach. So bleach and photosynthesis. Bleach or sodium hypochlorite is used to remove color or stains from fabric and also to kill germs. A bottle of bleach is kept in the lab in case of a blood spill. So it can be used to kill infections. Okay, so this is the stain. This is getting oxidized. This is losing oxygen, so it's getting reduced. So the oxidizing agent is bleach. Okay, and lastly, photosynthesis. Reduction occurs in photosynthesis. Carbon gains hydrogen, so this is reduction. And then you end up with a reduction on this side. And, oh, I see, this is split into two. Oxidation occurs when animals ingest carbohydrates to break them down to obtain energy stored in chemical bonds. So this is oxidation. So showing kind of both sides. So all of these applications that we've been going over, I don't expect you to memorize these, but if I give you examples and I kind of have it written out as such, you can kind of see how you see oxidation and reduction. And remember, look for the gain or loss of oxygen or the gain or loss of hydrogen. So oxidation, reduction, just a review. So gain of oxygen, reduction, loss of oxygen. Reduction, gain of hydrogen, oxidation, loss of hydrogen. So kind of a simpler way to keep them in check. So do your practice problems for Unit 4. It's really important. I've had a lot of students get very confused and mix oxidation and reduction up on the exam. So please don't be that student. Please take your time and study. You know, I want this to be easy for you. Remember your oil rig. Remember your Leo. The lion says grr. Oxidation and reduction in terms of oxygen and hydrogen. And like I said, practice, practice, practice. And after Unit 4, you just have Unit 5. And I'll explain this a few hundred times. But with Unit 5, you're going to have 4 options. You're going to have air, polymers, water, and energy. Okay? You just choose 2. That's it. Choose 2. So let's say I'm really interested in water and energy. I'm going to study those and watch those sets of lectures on water and energy, and then I'm going to take the exams that pertain to water and energy. Now your exams will not be released right away because I never know what students are going to take, so I have to go through and manually enter, look for air, see which students have taken air, see which students have taken polymers. Once I go to water and energy and find out that you've taken them, and let's say you got an 80 on each one, then your overall grade would be 80. But a lot of students ask, what if I take all 4? Do I get extra credit? You don't get extra credit, and I think it's a poor use of your time. So please just choose 2. Watch the lectures that pertain to those 2. And that's all you have to do for Unit 5. So if you're tempted to do air or polymers in addition to water and energy, just stick to 2 because you have enough coming up. You have your final coming up. So Unit 5 is two of these. Like I just chose water and energy. You can choose whatever interests you. The final is cumulative, and it covers units 1 through 4. It has 10 questions per unit, so it has 40 multiple choice questions. They're in chronological order, and let's say that you had a really bad unit 3, for instance. If you get all 10 questions correct on the unit 3 portion of your final, I will replace whatever your low grade is. Let's say it was a 43% on your unit 3, I will replace it with that 100. So it's nice. So I always tell students, if you had a really bad unit, to study hardest for that going into the final. So after unit 4, you just have unit 5 and the cumulative final remaining, and then you will be done with the course. But you need to get your lab work done in addition to this. But in terms of the lecture exams that you take, this is what you have left. And Unit 5 is I usually get several emails about this, and if you have questions, don't hesitate to email, because I know, it's getting towards the end of the class, and a lot of students, this is your last class that you have to take before you graduate, so I get that. But anyways, work on your Unit 4, study for the exam, and then think about what you want to study for Unit 5. And I'll see you for Unit 5.